let's talk about the coefficient of determination. It is often shown as a capital R squared. Now, it's great to talk about it. We can define it. But if you don't know why we're using this, what's the point? So let's start with this. If we have ourselves a scatter plot, so you see I'm dealing with quadrant 1, right, of the scatter plot, lots of dots all over, doesn't really matter. The red line that cuts through has a positive slope. We would call that the least squares regression line. Now, using that least squares regression line, we can use that to predict future values for whatever we are looking at of the relationship between the two variables represented by the x and y axis. So the coefficient of determination, r squared, lets us know, is that least squares regression line a good predictor of data? That is the entire point of r squared. So, does the independent variable give us a good prediction of the dependent variable? Right? So we're talking about x, y. So we're going to use r squared to determine if we have a good model. So r squared, do we have a good model to use as prediction for future variables? Okay, so r squared is going to be somewhere between 0 and 1. If it is 1, this is like a perfect predictor. Like, holy Moses, that is phenomenal. Very seldom is it a 1. If it is 0, this is like no prediction. Generally, we don't have a 0, we don't have a 1. Those are like the extremes, but it is inclusive. It could be 0, could be 1, somewhere in the middle. We're looking at decimals. Ooh, wrong button. So we want 0.8 or higher. If r squared is 0.8 or higher, we consider that a good predictor. So let's get it. I probably have that somewhere else. So to find this, now, if you are using technology, so Excel or a calculator or some other statistical software, you don't necessarily have to worry about this page. But if you are doing it by hand, you are going to use the sum of squares regression and perhaps the total sum of squares. If you don't know how to calculate those, you're going to need to watch a different video. But if we divide those, it gives us r squared. However, you may have the sum of squares due to error and the total sum of squares. If so, you can use those to also find r squared. There it is. The good predictor is 0.8 or greater. So anything 0.8 or greater, we'd say yes, we can use that least squares regression line to predict. Anything less than 0.8, we would say, nah, probably not. Let's look at two examples. If the sum of squares regression is 23.4 and the total sum of squares is 112.46, let's calculate r squared. Now, notice since we have these two, we are going to use the formula s squared equals SSR over SST. Let's plug in what we know. 23.4 divided by 112.46. When we divide numerator by denominator, I get 0.2081. That is, right, 0.2081 is less than 0.8. So we would say this is a bad predictor. The line that this came from would not be a great idea to use to predict future variables. Let's look at example 2. If the sum of squares due to error is 4.7 and the total sum of squares is 68.52, let's calculate r squared. Now, because we have the sum of squares due to error and a total sum of squares, we would use our 1 minus SSE divided by SST, and let's plug in what we have. So 4.7 divided by 68.52. That gives us 1 minus 0.06859, and this goes on, but I'm going to go ahead and round. So when I subtract those, I get 0.9314 and some change, right? Again, I rounded. But notice that is greater than 0.8. So this is a good predictor because 0.9314 is greater than 0.8. So that is kind of how we calculate r squared, what it means, and how to use it.